Hello, my name is Mr. Asprey and this is my Edexcel IGCSE exam questions series. This is number 52. This is sine and cosine rule. Let's get into it. So I've got on the side here, do you know a side and its opposite angle? If you have that information, then you're most likely, 99% of the time, going to be using the sine rule. And if you don't, then you're going to be using the cosine rule. So these are for non-right angle triangles, of course, because if it's a right angle triangle, you would just use trigonometry. And I've got the rules down here as well, so we're going to use those as we go. And the first question says find the area of the kite. So the area of the kite is telling me that I'm probably going to be using the area formula, like so. And a kite has a line of symmetry, which goes right down here between its two diagonals. So both of these two areas are the same. So let's work out the area of, let's call it this shape here. So the area of this is equal to a half as per the formula, and then it says AB. So AB are the two sides which are adjacent to, so next to, the capital C angle. So try not to worry about what the letters are, how they've been labelled, because most of the time they won't line up with actually the formulas themselves. But if we can think about the angle being capital C being this one, then A and B are the two sides which are adjacent to it. So we call that one A and that one B. So we could do 6 times 11, doesn't matter which way round the A and B are, just that they are the ones. And then sine of 118. Okay, so this will go into our calculator. Okay, and that gives me 29.1. So the area of the kite by symmetry is going to be 2 times by the area of the triangle we've worked out. Because they're exactly the same because of symmetry. So all we need to do now is just multiply this by 2. And our answer is going to be 58.3 to 3 significant figures, and that will be centimetres squared. Bosh. Next question, number 18, it says work out the value of x. Okay, well, let's use this rule over here. Do we know a side and its opposite angle? Well, no we don't. The only angle we know is this one, and we don't know its opposite side. So therefore, we're not going to be using the sine rule, we're going to be using the cosine rule. And the cosine rule has an angle, which is capital A. So this is going to be our capital A angle. Again, don't worry about these, almost forget about them. It's just going to put you off. That's the capital A, which means this opposite is the little a, which means these two are the little b's and the little c's. Okay, so we can work out little a first. I know it's not what we want, but this is a 5-mark question, so it means we're going to have to do two steps. So let's use the cosine rule, which is a squared is equal to b squared, which is 9.7 squared, plus c squared, which is 12.3 squared, minus 2 times 9.7 times 12.3 times by cosine of 115. Okay, so we can get a value from a squared by using our calculator. Okay, so that's gone into my calculator to give me this value for a squared. So then to find a, we just need to square root that. So I'll just put square root answer, and it's 18.6 centimetres. Oh, metres in fact. Okay, fine. Okay, so now we know this, we can put it onto our diagram, and then we can go back to the chart, and now we do know an opposite side and angle. So we know this and this, which means we can then use the sine rule, and that's going to help us work out the angle x, because we know its opposite side. So we've got a pair of sides and opposite sides, with one of them us needing to actually find. So if I'm trying to find an angle, I take the reciprocal of the sine rule. I just basically swap over the fractions. So I start with sine of the angle over its opposite side, which is 9.7, is equal to sine of what we know is 115 over its opposite side, which is 18.6. So doing it this way just makes it easier to rearrange. So to find sine x now, we just multiply both sides by 9.7. So we get this, like so. And then we can get a value for sine x by putting that into our calculator. Okay, so I've just put that in. I've got 0.4726. And then to find x, we just need to do the sine to the minus 1, the inverse function of sine. So just do that on our calculator. So we'll just take the whole value by doing sine to the minus 1 of the answer equals, and then this is our final answer of 28.2 degrees to three significant figures. And that is Bosch. Okay, next question, and it says that the area of the parallelogram is 18 centimeters. So what we're going to do is we're going to split this area up by drawing a line down like this to split it up into two equal areas because of the symmetry. And then, well, to use the area formula, we need an angle, don't we? So, and the angle is in between the two sides that we know. So we know this side and we know this side. So therefore this angle in here I'm going to call capital C. Again, don't worry too much about those. Just focus on where the angle is that you need. So we know the total area of this triangle is 9 because the whole parallelogram is 18, and we split it directly in half. So we can say that 9, the area, is equal to a half times AB, which are the two sides which flank the angle, multiplied by sine of the angle C. Okay, great. So let's just do some calculating here. Okay, so timesing those three things together gives us 11.59 times by sine of C. So then dividing by 11.59 will give us sine of C. And this will be 9 over that previous answer. And then what we'll need to do is to find C, we'll need to do sine to the minus 1 of this answer. So sine to the minus 1 of the answer, and that gives us a value of 50.9. Now it's important to note that the angle we've just found, it does tell us that it is acute. So whenever you find an angle using the sine rule or using sine, there is an alternative answer which you can get by doing 180 minus, and that will give you an obtuse angle. But we don't need to do that now because we're told that the angle is acute, and this is an acute angle, so we're good. Right, now we need to check which rule to use in this triangle in order to work out this line here, QS. Okay, so go back to our chart, and it says here, do we know a side and an opposite angle? Well, no, we don't. We don't have an angle and an opposite side that we know, so it means we have to use the cosine rule. So we now going to relabel the side because the angle that the cosine rule uses is capital A. So this is the angle we know. We're going to call that capital A, which means this is little a, and it means that the other two are B and C. Doesn't matter which order. So we're going to start by saying A squared is equal to B squared plus C squared minus 2 times B times C times cosine of capital A, which is 50.9. So we can get an expression for A squared now using our calculator. Okay, so just type that in and it's given us 22.4. So therefore we can square root. Get an answer of 4.73, and that will be centimeters, and that will be our answer. Bosch. Okay, next question, and we've got a circle theorem here. So the first thing I'm going to do is I know that this angle in here plus the 98 must add to 180 because it's a cyclic quadrilateral. So this is 82. Which means I've got two angles in here. Now what are they actually asking us for? They're asking us for the perimeter of the whole quadrilateral. Wowzer. So that means we need to know all the sides. Now we know this side and we know this side. So we just need to find the two sides on the other part of the quadrilateral, so these two. Now, I mean that's not obvious because the triangle ADC only has two angles, but if it has two angles it means we know all three. So this angle in here is going to be 82 plus 35, and then take that away from 180. So that is 117, which means this must be 63. Okay, but we're going to need a side length. So we're going to need that side length to come from the other triangle. So this side length here we're going to use. So looking at this top triangle here, do we have an opposite side, a side and its opposite angle? Well, no we don't. So we need to use the cosine rule on that top triangle. Now, the angle that we know in the cosine rule formula is capital A. So this is capital A. Again, forget the fact that the triangle is always labelled to mislead you. That's going to be capital A for now, which means that's little a, so we're going to use the cosine rule. So A squared is equal to B squared, which must be these two, B and C are these two. So 8 squared plus 7.5 squared minus 2 times 8 times 7.5 times by cosine of 98. Okay, so we can find out what that is just using our calculator. Okay, this gives us 136.95, so then we can find A by just taking the square root of that. So we get 11.7. Okay, perfect. So this is now 11.7. So now we can look at this second triangle here and what do we know about the second triangle? Well, in the second triangle, do we have a side and an opposite angle? Yes, we do. So we're going to use the sine rule because we have this and this, which is a side and its opposite angle. So we'll call this one capital A because it's an angle, and this one little a because it's a side. And then just we'll call this one little b, and therefore this angle is capital B, and we'll call this one capital C, so therefore this side length here is little c. Okay, so now let's use the sine rule. So to find little c, well, the formula is little c over sine of capital C is equal to the pair that we know, which is little a over sine of capital A. So we can rearrange this to get C is equal to multiply through by sine 63, so 11.7 over sine 82. Okay, so we can calculate that, and then we can also do the same to work out little b. So little b over sine of capital B, which is 35, is equal to, again, the pair that we know, like so, and then we can multiply through by sine 35 this time, like so, and that will give us our value for little b. So let's do that on the calculator. Okay, the first one gives us 10.53, and then let's do the next one. And this gives us 6.78. Okay, right, so finally, it's a real beast question this. The perimeter will be of this quadrilateral, all of these added up, the two that we've just worked out, and the ones at the start as well, so 7.5 and 8. So we will take our calculator there and add on 10.53, add on 7.5 and add on 8 to get the full perimeter, which is 32.8. Final answer, beast question that, bosh. Okay, next question, and we're asked to work out the area of the quadrilateral, which would be fine. We certainly can work out the area of triangle number 1 just by using the formula that we've got down here. So it's a half multiplied by, well, first off, identify the angle is always the key thing. This will be our capital C. Forget about what they're labelled, because that's just there to confuse us all. This one will be capital C, which means the side opposite will be little c. But this one will be B, and this one will be, and then A and B are the other two, doesn't matter which order. So we can work out the area of this by doing a half times by 12 times by 9 times by sine of 60. So we can get that into our calculator. So 0.5 times by 12 times by 9 times by sine of 60 is 27√3. Might as well leave it in exact form for now. Okay, so that's great, but now we want to find the area of number 2, but we don't have enough information because we need an angle, but we need two sides that are either side of the angle. So we need this side length. So we're going to use this triangle to find it. So I need to relabel. So now, do we have a side and opposite angle inside of this first triangle here? No, I don't. So therefore I'm going to be using the cosine rule. Now the angle in the cosine rule is capital A. So this angle now becomes capital A, which means this side is little a, which means these are now the B and the C's. So we write a squared is equal to b squared plus c squared minus 2 times by bc times by cosine of 60. That goes in our calculator to work out a. Okay, so we get 117, which means that a is equal to the square root of 117. Perfect, so we can now relabel this the square root of 117, and then we can work out the area of triangle number 2 using the formula. Now, once again, we need to relabel, because the formula for the area of triangle, the angle is capital C, so this is capital C, which means the sides, either side of it, are the A and the B. So, if the A is the square root of 117, and the B therefore is 7, and we've got sine of 84, that can go in our calculator. Okay, and this gives us 37.7, and I think we're good then. So therefore the total area is equal to 27√3 plus 37.7. So we'll take that and we'll just add on 27 times by √3, and we'll get 84.4, and that will be in centimeters squared, and that is bosh. Okay, we've got a triangle here, and it says that, given that the angle is obtuse, so alarm bell should be ringing now. This is the ambiguous sine case, where we're not sure. Well, the sine rule gives us two different possible answers when trying to find an angle, and we need to distinguish which one is which. Okay. So this angle in here is the obtuse one. It says work out the area of the triangle. Now that would be very helpful. It would be very helpful if we had this angle, because this angle here is flanked by two sides that we know, which will mean we'll be able to use the area. But we don't have that angle. But what we do have is we have a side and its opposite angle, because we have this one and we have this. So we can use the sine rule here, and that will then allow us to pair up these two. And then once we've got those, the yellow angle, that will then allow us to work out the green angle, just because angles in a triangle at 180, and then we'll be good to go. Okay, so the sine rule, let's do it up here. If I'm trying to work out an angle, I always write sine of the angle we're looking for, let's call it x, on top, over the side length, which is opposite, is equal to the other pair, so sine of 18 over the side length is opposite. So sine of x is therefore equal to sine of 18 over 1.6 multiplied through by 4.2. So we can do that on our calculator, and we get 0.8111. So x is equal to sine to the minus 1 of 0.8111. Okay, so we go to our calculator and we do sine to the minus 1 of the answer, and we get 54. So on the first look, it would seem that the answer was x was 54.2, but it does say that x is obtuse, so therefore that is the first possible answer for x, but there is a second answer which we can get by doing 180 minus the first answer. Okay, so that's what you have to do when you're using the sine rule. There are always two possible answers, one obtuse, one acute. And if you want the obtuse one, you have to do 180 minus. Okay, so that is our yellow angle. So now to find our green angle, let's call it theta. So that will be 180 minus the blue minus the yellow, like so. So we could do that on our calculator. We do 180 minus the previous answer minus 18 as well. So we get 36.2. And now we can use the area of the triangle formula, because if we relabel and call theta capital C, then this means that this is opposites, that's little c, which means these other two are A and B. So we can say that the area is equal to 1/2 times A times B times by sine of the capital C angle, or the green angle, which we worked out was 36.2. So we could just do that on our calculator, 0.5 times 4.2 times 1.6 times sine of that previous answer, and we get an answer of 1.98, and that is to three significant figures, and that is centimeters squared. Bosh. Okay, next one is super tricky, really tricky question this. We have a shaded area T is formed by removing an equilateral triangle from a regular hexagon. Now, the first thing that I know is that a regular hexagon can be split up into 6 equilateral triangles, like so. So I think that might be quite helpful, given that we've already got an equilateral triangle in here. Okay, it says that points P and Q lie on AB such that AB is equal to 1.5 times PQ. We know the area of the shaded area, and it says find the length of PQ. So because we're trying to find the length of PQ, we might as well make PQ the variable, or the unknown, should I say. And let's just call that X. So if PQ is X, like it says, then that means that AB is equal to 1.5 times PQ. So AB is equal to 1.5 times X. So these grey triangles that I've created, they're all equilateral, and they all have a side length of 1.5x. So that's 1.5x, that's 1.5x, and along the top there as well, that is 1.5x. Okay, so let's now create an equation which is going to link the area of the shaded region So the area of the shaded region is 72 root 3, and that's equal to, well, first off, it's 6 grey triangles. It's not the most formal way of doing this, but you get the idea. Minus just one of the white triangles. So if that's the grey triangles, then minus one of the smaller white triangles. Okay, so what is a grey triangle? How do we work it out? Well, we know if I just take this one here, we know we've got 1.5x as all of the sides, and we also know the angle inside is 60 because it's an equilateral triangle. So, using the formula for the area of a triangle, the grey triangle is 1/2 times by the two side lengths either side of the angle are both 1.5x, and then multiplied by sine of the angle, which is 60. Perfect. And then we've got to take away a white triangle. Well, what's a white triangle? Well, again, it's an equilateral triangle, so it's got an angle of 60, and each of the side lengths here are just x. So by the formula, it's 1/2 times x times by sine of 60. Let's just move that over there so I can fit it in, times by sine of 60. Okay, perfect. And all of this is equal to 72 root 3. Okay, so now we could do a little bit of cancelling down, can't we? So we can take the 6 times by 1/2. So we do 6 times by 1/2 times by 1.5 times by 1.5. So that gives us 27 over 4. And then there's an x and an x, so that makes x squared. And then we're also timesing that by sine 60. I'll just leave it like that for now. Minus, over here, we've got 1/2 x squared times by sine 60. Okay, next we can spot that both of these terms have an x squared sine 60. So we can collect up however many x squared sine 60s we have. We have 27 over 4 minus 1/2. So overall we have 25 over 4 x squared sine 60s. So that's 25 over 4 x squared times sine 60. But what is sine 60? Sine 60 is root 3 over 2, so times by root 3 over 2, and then times by the x squared. Okay, great. So what we can do next is we can just combine these two fractions to get 25 root 3 over 8 x squared. We can then divide through by root 3 on both sides. And then we can take that 72 and we can divide both sides by the 25 over 8. So we get this. So we get 576 over 25 is equal to x squared. So therefore x is equal to the square root of this, which is 24 over 5. Perfect. Bosh. Done. And then the final question, I've already done this on my channel, so I'm just going to edit in me doing the final question, which I did like about a year ago. So enjoy that. See you later. Let's do it. So the first thing I'd want to do is I'd want to find as much information as possible. So I can label my diagram. I can see this is going to be 5 centimeters because it's a radius just like this one up here. And I can see this one's going to be 4 centimeters, just exactly the same reason. What I think would be really helpful is if I found this distance right down there, and also if I could find this angle in here, let's call it alpha, then that would also be really helpful. Okay, so let's start off with AB, this well, it's a chord essentially of the circle. Now, how am I going to find that? I'm going to use the cosine rule on the left triangle. Now, the cosine rule states that a squared is equal to b squared plus c squared minus 2 times b times c times cosine of capital A. Now, capital A is the only angle in that formula, and the only angle we have is this one here, which is 50, which means that that angle points to the chord we're trying to find. So the chord we're trying to find is little a. So I can write AB squared, because that is the name of the chord, goes from capital A to capital B, is equal to, well, little b and little c, those are the two other sides of the triangle, which are both 5. So 5 squared plus 5 squared minus 2 times 5 times 5, and then times by cosine of capital A, which is 50 degrees. Okay, great. So that's going to give us a value, and then I can square root that to find whatever, well, AB is. And that gives me a value of 4.226 when I put it into my calculator. Okay, fantastic. So that's good. And what I want to find now is alpha, the angle on the other side of the other triangle. So in order to do this, I need to use the cosine rule again, but I need to reverse it so that I can find an angle. So I need to rewrite the cosine rule. Now, I never remember what the cosine rule is for the angle, and you're not giving it in the formula booklet either. So what you can do is just rearrange this equation up here. So this big slab, which is minus 2bc cosine A, I can add that to the other side of the equation. So that becomes 2bc cosine of capital A plus A squared is equal to b squared plus c squared. I can then subtract the a squared, like that, and then I can divide through by 2bc. And that gives me my formula for cosine capital A. Okay, well, what is capital A? It's the angle, and the angle we're trying to find is alpha. B and C are the two sides kind of opposite, not opposite the angle, adjacent to the angle, which are both 4 in this case, so it's 4 squared plus 4 squared. A is the side opposite the angle we're looking for, which is the chord, which is the one we've already worked out, which was 4.226, and that's all divided by 2 times 4 times 4. Okay, so we can get a value for that. It will be a decimal value, and then we'll take the inverse of cosine to find alpha, and we get an angle of 63.77 when we put that into our calculators. Okay, brilliant. That's really helpful. Right, now we need to start actually finding the area of this thing. So what I'm going to do is I'm going to start by finding the area of this this sector here. So that's the segment, but the whole sector looks like this. Okay, so that's what I'm going to find first. Okay, so the blue sector there, well, to find the area of a sector, it's the same as the area for a circle, but what we need to do is take a fraction of it, and that fraction is the angle of the sector over 360. So times by pi times by r squared. Okay, great. So that's the whole sector, but I don't actually want the whole sector. What I really want is just the segment at the end. So the bit between the chord and that rest of the circle. So what we could do is subtract the triangle. So if I take away that triangle, it looks like that, and that's exactly what I want. Okay, so how do I find the triangle? Well, the area for the triangle is a half AB sine C. Again, that's in your formula booklet. Now, what does that mean? Well, if you've got an angle, a triangle, sorry, and you know the angle, call it capital C, A and B are the sides adjacent to the angle, we can always find the area. So it's a half of A, which is 5, and B, which is 5, times sine of capital C, which is 50. Okay, great. So that gives me my blue area, which is, when I put it to my calculator, 1.33. Fantastic. So what am I going to do next? Well, I'm just going to do exactly the same thing on the other side. I want this little segment in here, but what I'll need to do is find the whole sector. And again, the sector is the angle, which is alpha, which is 63.77, over 360, multiplied by pi times by radius squared. And then that gives me the whole sector, but I want to get rid of the triangle because then I'll be left with just that segment, which is exactly what I'm looking for. So I need to subtract the triangle, which is, again, using the area formula for a triangle, it's a half AB, which are the two sides adjacent, which are 4 and 4, times by sine of alpha, which was 63.77. And that gives me an angle, when I put that into an area, when I put that into my calculator, of 1.73. Okay, right, we are looking good to finish this question up now, because what I'm going to need to do to find the area of R is just add together these two areas, which I found out already. And that gives me a total of 3.06